In this video, we want to continue our series on coordinate geometry by talking about the midpoint of 2 points. In the previous video, we've talked about how to plot this point on a Cartesian plane or a rectangular coordinate system. We've also been able to look at how to derive the distance formula and how to apply that in finding the distance between 2 points. Now, in this video, we want to look at the midpoint of 2 points. What do we mean? So let's say we have a straight line like this. So let's say we have a straight line like this. So let me call this, let's assume that this part is 3 and this part is 9. If I were to look for the midpoint, if I were to be looking for the midpoint of this line that has this junction here is 3 and the junction here is 9, what I simply need to do is to add them together. 3 plus 9 divided by 2. So 3 plus 9 gives me 12, and 12 divided by 2 will give me 6. So that means the midpoint of this line will be exactly on 6. So that's what we want to do here. But this time around, for this one, we only have one axis. This time around, we're having 2 axes. So we're going to first of all look at how to derive the formula to find the midpoint given 2 points. And after that, we're going to take a question and see how we apply the formula. So we've been given 2 points, A and B. 2 points A and B, and the coordinates of A, we're giving it to be x1, y1. The coordinate of B, we're giving it to be x2, y2. And then we're told that point C divides line AB in its midpoint in such a way that line C now has a coordinate of xc, yc. Now, how can we use this to find the midpoint or to derive an expression to calculate the midpoint given 2 points? Now, very easy. We're going to be using the concept of similar triangles. Similar triangles. Remember, if two triangles are similar, then you can take the ratio of their sides together and it will be equal to a constant value. What do I mean? So if this is, you can say here I have 2 triangles. First of all, I have AC and also I have CB. Now this is angle 90. This also here is angle 90. Now 2 angles are equal, so definitely this is 90, this is 90. Then the angle here, angle C and angle A are also equal. So hence these triangles are similar. So what we want to do, we can now say that AC, that is side AC over CB, AC over CB must be equal to AD, that is the base of this triangle AD over CF. I repeat myself, by using the concept of similar triangles. How do we know 2 triangles are similar? Either all sides are equal, that's one way to ascertain that 2 triangles are similar, or 2 angles and the side are equal, or 2 angles are equal, because if 2 angles are equal, then definitely the third angle also will be equal. Now we said this is angle 90, definitely this also will be angle 90. Now if that is true, then the angle here, the angles of C will definitely be equal to the angle of A. So from geometry, so this is easily tested because they're actually corresponding angles. So because of that, we're able to take the ratios, that is AC from this point to this point, if it is AC, and then from this point to this point, if it is CB, if we take that ratio to also be equal to AD over CF. Now that we've said this, now we can also say AC can also be equal to CB. AC can also be equal to CB. Why are we saying AC is equal to CB? Because we are told that this line C here divides AB at the midpoint. If line C divides AC, if line C rather, or point C divides AB at the midpoint, then I can also come to this conclusion: AC is equal to CB. Then definitely, it must mean that AD must also be equal to DE. So AD will be equal to DE. Why? Because point C divides line AB into 2 equal parts. Okay, now let's see what we can bring out from here. Now this is point A and this is point C. It must mean that in between them on the x-axis, this will simply be xc minus x1. xc minus x1. Where did we get this from? Remember what we did in the last video. This pointer is xc, this pointer is x2, this pointer is x1. So from here to here is x1, and from here to here is xc. So it must mean in between will simply be xc minus x1, hence what we've written here. Now if this is xc minus x1, then it means that this will be x2 minus x1, isn't it? Sorry, x2 minus xc, not x1. So let me write that properly so it doesn't confuse you. So x2 minus xc. All right. So now that we've come to this conclusion, then we can now write or equate them. Since we already said AD is equal to DE, and then we're trying to find the midpoint. And in order to find this midpoint, first of all, I have to look for the midpoint on X and also apply the same logic to look for the midpoint on Y. What do I mean? If AD is equal to DE, what is my AD? AD is simply XC minus X1. Okay? Now, what is my DE? So this will be equal to DE is X2 minus XC. Remember, I'm looking for the X coordinate system, the coordinate system of the x value at point C. How do I find it? Because point C will be the midpoint. So it must mean that I must make xc the solution from now. So take negative xc to this side, it becomes positive, and takes x1 to the other side, becomes positive also. So here I'll be having 2xc would be equal to x1 plus x2. And finally, xc will be equal to x1 plus x2, everything divided by 2. So in order to find the midpoint, in the x-axis only now, you take the first x, add it to the second x, and divide it by 2. Just like the example or demonstration we did before we started the lecture, where we have a line 3 and 9 at different places, add them together and divide it by 2, you get the midpoint, so which is what we derived here. But this only holds true for the x coordinates. Now for the y coordinates, we'll be doing the same exact thing. Already we already know that for yc will simply be equal to again y1 plus y2 all over 2. But how do we get this? So let's see what we can denote from that. Again, if this point here, this point bf, so let me call this bf. This bf will be y2 minus yc, and then fa will be yc minus y1. So why is that so? Same thing we did there for x minus x1, x2 minus xc. So if this is point C has a midpoint y coordinates of yc, and this is y1. So definitely, if this is yc here, and then this is y1 here, and then this is y2 here. So if I'm looking for the distance between y1 and yc, so knowing that from 0 to this is yc, and from 0 to this is y1. So the distance between y1 and yc will simply be yc minus y1, so which is what we've written here, and so also y2 minus yc. So we can now say, since C divides line AB at the midpoint, then definitely BF would be equal to FE. Now if these two are equal, then we can say y2 minus yc is equal to yc minus y1. Again, take this yc to this side, bring y1 to this side, so it becomes y2 minus y1 is equal to 2yc, and then divide both sides. Sorry, this should be plus, because y1 leaves the left hand side, moves to the right hand side, becomes positive. So at the final yc will be equal to y2 plus y1 all over 2. So this is the formula to calculate our midpoint. But after this, we still need to write them in an ordered pair. So let me try and erase the screen and see how to write all these things that we've said. So formula for midpoint of the line segment. So it will be given as x1 plus x2, everything divided by 2, comma, y1 plus y2, everything also divided by 2. So if you're given a question and you're asked to find the midpoint, so what you simply need to do is add the x values together, divide it by 2, that will be the midpoint on x, and add y values together, also divide by 2, that will be the midpoint in y. So let's take an example. So let's say we're given 2 points, a to be minus 3, 2, and then b is equal to 4, negative 6, and we're being asked to find the midpoint of these values. Remember, in the previous example or in the previous video, we looked at how to find the distance between these 2 points. But for the sake of this example, we only want to find the midpoint. So for the midpoint, so what will be my x midpoint? So what do I simply need to do? Label the coordinates. So let's say this is my x1 and this is my y1. This will be my x2 and this will be my y2. So from the formula, we add the x together divided by 2. So I can say minus 3 plus 4 divided by 2, then comma. Then for the y-axis also do the same thing. 2 now plus minus 6, so it becomes 2 minus 6 divided by 2. And then what do I have? Minus 3 plus 4, that's plus 1. So my m here will simply be equal to 1 over 2. That's for the x value or for the abscissal. y2 minus 6 is negative 4. Negative 4 divided by 2, that's negative 2. Y minus 2 will be my coordinate or my y value. So all these concepts makes perfect sense. In the next example, I'm going to be looking at the division of a line in a given ratio. That is how to find the internal division of a line given a particular ratio. Thank you for watching, and bye-bye.